ever stared into your microwave, watching your food spin, and wondered about that weird mesh pattern on the door? You see it, you peek through it. But what's it actually for? Is it just for decoration? Or is there a bigger secret hiding in plain sight? Well, get ready, because today we dive in deep into the science behind that simple-looking door and uncovering the fascinating reason it is one of the most important parts of your microwave. So, let's start with the basics of how a microwave oven even works. It's all about, you guessed it, microwaves. These are a type of electromagnetic wave, just like radio waves or the light from the sun. But they have a very specific superpower when it comes to your food. Inside that metal box, a device called a magnetron generates these microwaves. Think of it like a tiny, powerful radio station, but instead of broadcasting music, it's broadcasting energy. Now, these waves are shot into the cooking chamber, which is essentially a metal box. Why metal? Because metal reflects microwaves. So once they're inside, they can't get out. They just bounce around and around, hitting your food from every possible angle. This is great for cooking, but it raises a pretty important question. If these powerful waves are trapped inside, how do we get to see our food without getting zapped? And that, my friends, is where the magic of the microwave door comes in. The secret lies in that black, grid-like mesh embedded in the glass. This isn't just any old screen. It's a precisely engineered shield known as a Faraday cage. A Faraday cage is an enclosure used to block electromagnetic fields. The one in your microwave door is a perfect example of this principle in action. It's made of a conductive material, usually a thin layer of metal, with a pattern of tiny holes punched into it. Now here's the really cool part. The size of these holes is absolutely critical. Microwaves, like always, have a specific wavelength. For the typical microwave oven, this wavelength is about 12 centimeters or roughly 5 inches. The holes in the mesh on your microwave door are designed to be much, much smaller than this wavelength. We're talking just a couple of millimeters across. Because the holes are so tiny compared to the size of the microwaves, the waves simply can't pass through. To them, that mesh screen looks like a solid metal wall. They hit it, they see it as an impenetrable barrier, and they bounce right back into the cooking chamber to continue their job of heating your leftovers. It's an incredibly simple yet effective way to contain all that cooking energy safely inside the oven. But wait, if the microwaves can't get through, how can we see our food? This is where another property of waves comes into play. The light we see with our eyes also consists of electromagnetic waves, but visible light has a much, much shorter wavelength than microwaves thousands of times shorter. In fact, the wavelengths of visible light are so minuscule that they can easily pass right through the tiny holes in the mesh. So, you have this brilliant piece of engineering. The holes are small enough to block the long wavelength microwaves, keeping you safe, but they're large enough to let the short wavelength visible light pass through, allowing you to check if your soup is about to boil over. It's the perfect compromise between safety and convenience, all thanks to some fundamental physics. The design of this mesh isn't left to chance. There are strict international safety standards that dictate how much microwave radiation can leak from an oven. Manufacturers have to calculate the hole size and spacing with extreme precision to ensure their appliances comply with these rules. The goal is to keep any potential leakage to a level that is far below what could be considered harmful. So that little grid is your personal bodyguard against invisible energy waves. And this principle isn't just for reheating your pizza. The concept of using a mesh to block certain electromagnetic waves while allowing others to pass has applications in many other high-tech fields. For example, scientific laboratories that work with sensitive electronic equipment often use rooms shielded with a similar metallic mesh to prevent outside radio waves from interfering with their experiments. These are called RF shielded rooms or Faraday cages. Even modern aircraft use a similar idea. The body of an airplane is essentially a large metal tube. If it gets struck by lightning, the metal skin acts as a Faraday cage, conducting the massive electrical charge around the outside of the plane and safely discharging it, protecting the passengers and sensitive electronics inside. It's the same core concept, using a conductive enclosure to control and redirect electromagnetic energy. The cockpit windows of some aircraft even have a very fine, almost transparent metallic mesh embedded in them too. Protect the flight systems from external interference and lightning strikes. So the next time you're waiting for your popcorn to finish popping, take a moment to appreciate that humble little mesh on the door. It's not just a window. It's a sophisticated piece of physics and engineering. It's a selective filter, a safety shield, and a perfect demonstration of how we can manipulate the invisible forces of the universe for our everyday needs. It lets the good stuff light come out while keeping the powerful stuff microwave safely inside, doing its job. It's one of those amazing little details of modern life that we see every day but rarely think about. A simple solution to a complex problem, all hidden in plain sight. Thanks for watching and getting curious with us today. If you enjoyed uncovering this little secret, imagine what else is hiding in your home. Don't forget to hit that subscribe button and ring the bell so you never miss another deep dive into the world around us. See you in the next one.